In this lesson we're going to look at another equation involving the wave function. So we've got to solve cos theta minus root 3 sin theta equals 1 for 0 is less than or equal to theta is less than or equal to 360. So again, expand the first part out using the addition formula. Forget about the 1 until the end. We'll talk about that once we've actually changed this part here into the wave function, or k cos theta minus alpha. So let's do that. So let's look at coefficients first. So k cos theta is k cos alpha, sorry, is the coefficient of cos theta, and if we look up here, that's a 1. So we can write that down, 1. So cos theta is equal to 1 over k, cos alpha, sorry. Get my alphas and my thetas mixed up here. Next, look at k sin alpha, and that's the coefficient of sin theta. So we look up to sin theta, and that's here, and the coefficient is root 3, but it's a negative. And since there's a plus here, k will have to be negative root 3. So sin theta is equal to negative root 3 over k. Alpha's here. Again, fill out your triangle with your opposite side, so that's opposite the angle, negative root 3. K is going to be the hypotenuse here, and 1's your adjacent. So by Pythagoras, you have got, oops, I rubbed that out. By Pythagoras, we've got the square of 1 plus the square of negative root 3, and then we square root it. So again, that's going to go to 3 plus 1, which is 4. Square root 4 and you get 2 again. Moving down to this part, we can see that cos is positive and sin's negative. Tick which quadrants cosine's positive, A and C. Sin is negative down here and here. So we're looking at a fourth quadrant solution. So tan of alpha is equal to negative root 3 over 1. Find your relative acute angle, inverse tan root 3, which is 60. But we're looking for a fourth quadrant solution here. So take it away from 360 to get your fourth quadrant solution of 300, and then rewrite it. So we've got cos theta minus root 3 sin theta equals 2 cos theta minus 300. Now the equation was this, solve this equal to 1. So we're going to look at that in this second part of the question. So because we have worked this out to be 2 cos theta minus 300, we can rewrite this part here. This part here can be rewritten as this here. So we'll do that. I can then try and solve this to find theta. So divide by 2 to get a half, and then look for 2 solutions. You should always look for 2 solutions when you inverse cos. In the last example we had negative 1, so when you inverse cos negative 1 there only is one solution, because if you think about the cosine wave, and I'll draw a bad cosine wave here, but negative 1 is here and there only is one solution, but the rest of the values have 2. Apologies for that cosine. Okay, so if we inverse cos a half, there's 2 solutions. Cos is positive, so you've got your first quadrant and your fourth quadrant. So if you inverse cos a half, then you're looking at your base angle of 60. So basically you've got 60 degrees, or 60 back from here. So 60 or 300 from this here. Just a wee reminder, every time you inverse sine, cos or tan, you must look for 2 solutions. Occasionally, like I described there, there's only one, but most of the time there'll be 2 solutions. We're then going to finish off by, well, there's a few things to do, but we'll add 300 to both sides here. So 360 or 600 degrees. Now, in the question, it asked for all the solutions between 0 and 360. So we can use periodicity to work all these solutions out. If there's a solution at 360 degrees, that means there's also a solution at 0. So we've got 0 and 360. And if there's a solution at 600, that's out with our range, so we go back 360 degrees to get the value between 0 and 360 that's the same as this. And if you take 360 away from that, you get 240. So if we go backwards and forwards 360 degrees from these solutions, we can get all our solutions. So 360 is one, 0 is another one, and go back 360 from here to get 240.